We continue the review with another compound inequality. 2x plus 1 is greater than negative 3 and less or equal than 9. So the procedure is the same. We isolate the variable x in the middle. So first we subtract 1 from all three parts of the inequality. We have 2x in the middle, negative 3 minus 1 will be negative 4, 9 minus 1 will be 8. So here we can have less than or equal side. Then we divide by 2, all three parts of the inequality. We get x in the middle, greater than, less than, or equal. Negative 4 divided by 2 will be negative 2. 8 divided by 2 will be 4. So x is greater than negative 2 and less or equal than 4. On the number line, it looks like this. This is greater but not equal to negative 2. Here is 0. Here is 4. It's less or equal than 4. So sometimes we use empty dot and closed dot. Sometimes we use parenthesis and square bracket here, and x can take any value between these 2 points. Important how to write it in interval notation. So we have parenthesis on the left, square bracket on the right. It means that 4 on the right is included and negative 2 on the left end is not included. So the interval from negative 2 to 4 with the right end included. Find the slope of the line passing through the pair of points. So 4 and 1 and 4 and 5. The slope is given by the formula, the difference of the change in y over the change in x. Change in y is the difference of y coordinates, y2 minus y1. You can use y1 minus y2, but you have to use the same order in the numerator and the denominator. It is better always use the same orders. y2 minus y1, x2 minus x1. So y2 minus y1 will be 5 minus 1, 4. But we have the same x component, so it is not we cannot divide by 0, so slope is not defined. It means that it is a vertical line. Let us take another pair of points. So in all this example we have something special. Let us consider another point, a pair of point 4 and 1 and 3 and 8, these 2 points. Then the slope will be change in y divided by change in x. 8 minus 1 divided by 3 minus 4. So 7 over negative 1, so negative 7. So here also let us change it by negative 8, negative 8, or negative 8, negative 9, to have different points. So these 2 points, and find the slope between these 2 points, slope of the line. So change in y divided by change in x, y2 minus y1 divided by x2 minus x1, y2 negative 9 minus negative 5, so minus 5, and change in x, negative 8 minus 4, so we have negative 9 plus 5, negative 4, negative 8 minus 4 minus 12, negative divided by negative, we get positive number 4 over 12. We can divide by 4 numerator and denominator, we'll get 1 over 3. Write an equation for the line in point-slope form or slope-intercept form, passing through the point -3, -5, and parallel to the line whose equation is y equals -5x plus 3. So, our line must be parallel to this line. It means that it has the same slope. The slope of this line is the coefficient by x, -5. So our line will have the same slope, y equal -5x, but the intercept, y-intercept will be different, will be plus b. To find this b, y-intercept, we can use this pair of points. They are x and y coordinates of the point on the line. So if this point is on the line, it means that this x and y, -3 and -5, satisfy the equation of the line. We substitute them, so -5 for y and -3 for x equals -5 times -3 plus b, and we get the equation in b. So we have -5 equals negative times negative positive 15 plus b. Subtract 15 from the left and from the right. -5 minus 15, -20 equals b. So substituting this b in the original equation, we get that y equals -5x minus 20, the equation of the line parallel to this line and passing through the point -3, -5. Find the distance between the pair of points 8, 7 and 4 and 4. The distance formula d equals the square root difference of x components squared, x1 minus x2 or x2 minus x1, doesn't matter since it is squared, plus y2 minus y1 also squared. So difference of x component, x1, x2, so 8 minus 4, so square root 8 minus 4 squared plus difference of y component 7 minus 4 or 4 minus 7, it doesn't matter, let's write 4 minus 7 squared. So it doesn't matter which order you write these numbers, you will get -3 or 3 squared, both will give 9. So square root of 16 plus 9 will be square root of 25, which is 5. Distance is always positive. So another example, let us make different numbers. So 4 and 3 and -1 and 7. Let us find the distance between these 2 points. Distance is the square root difference of x components, so 4 minus -1 and then squared plus 3 minus 7 squared, difference of y components. 4 plus 1 is 5, 5 squared is 25, 3 minus 7, -4, -4 squared is 16, plus 16, 25 plus 16, 30, 41, square root of 41. Next example from chapter 3 about the parabola. Write an equation in standard form of parabola that has the same shape as the graph of 7x squared or -7x squared. So you know next 7x squared is the parabola opened upward, and -7x squared is the parabola open downward. Yes, -7. So this one has a minimum, this one has a maximum. So what do we want to find with the given maximum or minimum? And we are given a maximum. Maximum at maximum equal 1 at x equal -8. So we have a maximum at the point -8, 1. So x is -8, y is 1. So it means that -8 and 1 is the vertex of the parabola. Parabola has a maximum. It means that it will have -7, the coefficient. So, and the parabola in vertex in standard form is y equals, so the coefficient will be -7 times x minus x, the x component of the vertex is denoted by h, I think, minus h squared plus k as general or standard form of the parabola with a given vertex. So vertex. Now we have -8 and 1. So our parabola will be -7 times x minus 8. So -8, so x plus 8 squared, and subtract 1. So this is the horizontal shift, the opposite in the negative direction, -8. And this is the vertical shift. Oh, sorry, plus 1. So horizontal shift is added, vertical shift is added, horizontal shift is subtracted from x. Write an equation of the parabola that has the same shape as the graph of f equals 2x squared or -2x squared, but with a given minimum. Minimum means parabola is open upward. So we have the function like this, like with the coefficient 2, with positive sign, x minus h, the x coordinate of the vertex squared, plus k. So, and our minimum is 0, so k is 0, and h, the x coordinate of the vertex, is 12. So the parabola has in equation 2 times x minus 12 squared plus 0. So the polynomial inequality. So to solve polynomial inequality, we must find the boundary points, the zeros. So it means that we must factor this quadratic function. So here possibly we don't have to use a quadratic formula, we just use trial and error and find two numbers. They have a product equal to 21 and the sum equal to 10. So let us try 3 and 7. They must have the same sign, so the product is 21, either both positive or both negative. The sum must be negative 10, so both must be negative. X minus 3 times x minus 7, and this equation, this product must be greater than 0. So let us consider the real number line. Two zeros are 3 and 7. They are both open dots since we have greater sign. 3, 7. Be careful, they are not -3 or -7, but +3 and +7, since they are the solutions of the equation x minus 3 equals 0 and x minus 7 equals 0. So x equals 3 and x equals 7. They are the boundary points, and this product can only change its sign at boundary point. So between and outside the boundary point, it has the same sign, so positive or negative. So, and here we can use the trick with the graph of this polynomial function. You know that it is a parabola. Since here is plus, you know that it is a parabola opened upward. So if you make the graph of this parabola, it will be something like this. Opened upward, it will be positive here outside of the interval and negative inside between 3 and 7. If you are not sure how to plot this parabola, you can pick up a point from each of the intervals, or for example, from this interval you can take x equals 0, substitute in the equation 0 minus 3 times 0 minus 7 is negative times negative is positive, greater than 0. From this interval, you can pick up the point like 5, x equals 5, 5 minus 3, 5 minus times 5 minus 7, positive times negative will be negative. See? And in the third interval, for example, you can pick up x equals 8 and find the sign of the product 8 minus 3 times 8 minus 7. Of course, it is positive. So either way, both will give the same result. So our product is positive outside of the points 3 and 7 and negative inside, and it is equal to 0 at the points 3 and 7. So we solve the equation. We want to find the interval or intervals where it is positive, greater than 0, but not equal to 0. So that's why the point sign excluded. And these are two intervals from negative infinity to 3 and from 7 to positive infinity. So we use parentheses since the boundary points are excluded, and infinity is always excluded because it's not reachable. You cannot reach infinity, you cannot include it into the interval. Let us solve another polynomial inequality. Again, we have a quadratic function. Its graph is a parabola open upward. You can use it. But first, let us find the boundary points. Let us solve the equation x squared plus 5x plus 4 equal 0. So we can factor it again by trial and error. We can find two numbers such as the product is 4 and the sum is 5. So possibly it will be 1 and 4, and they have this, and they both are with plus. 1 times 4 is 4, 1 plus 4 is 5. So the solution of the first zero, the solution of x plus 1 equals 0 is x equal -1. And if you put x plus 4 equal to 0, you will get x equal -4. So we have -4, -1, and we have less than or equal sign. It means this boundary point will be included into the interval. I can show it by the closed dot. So now we have to choose intervals where this function is negative is less than 0. So you can use the graph of the parabola. Just open upward, so you can tell that the function is negative on this interval and positive on these two intervals, or you can pick up points from each intervals. So less than 4 will be x equal -5. Substitute -5 in this or that equation. So Either way, you can use the original one. So -5 squared, 25 plus 25 plus minus 25 plus 4, positive, greater than 0. Then the middle interval, let us take x equal -2 from this interval, but not the boundary points. -2 squared is 4, -2 times 5 minus 10 plus 4 is negative. And so it's easier to substitute in this in the factor equation, but we can substitute in both of them. And the last one, let us take 0 for the third interval and substitute. This time it is easier to substitute in the original equation will be 4, and it is greater than 0. So we got the same result. It's positive, it's greater than 0 in the ends, and it is less than 0 in the middle. So this equation, this polynomial will be less than or equal than 0 on the interval from -4 to -1, including the ends of the interval, since we have less than or equal sign.